Hello, I am Sunita. Welcome to my class. Here I am going to discuss Gpstr 2017 Science Solved Question Paper Part 2. This is my fourth class. Let us start the class. Let us discuss first question here. For which order reaction the unit of rate and rate constant are same? At which order reaction? Here n we will call it as a order of a reaction. In which order rate of a reaction it will be equal to rate constant. They are asking the question. They are given the option A 3, option B 2, option C 0, option D 1. Let us discuss in detail. Consider a simple reaction. A gives to B. Here A is the reactant, B is the product. Here only simple reaction I am considering to understand the concept. Then R it will be equal to K into A to the power of N. Here R is the rate of a reaction, K is rate constant. This A, this concentration of the reactant, here reactant, N is the order of a reaction. These terms you have to remember. Then let us see what is meant by a rate of a reaction. Reaction rate in chemistry, the speed at which a chemical reaction proceeds. At what speed the reaction it will complete. Otherwise, speed of a reaction we will call it as a reaction rate. You can observe sometime we will call it as a slow reaction, sometime we will call it as a fast reaction. That it will refer to a reaction rate. It will indicate the speed of the reaction. Then how we will express the unit of rate of a reaction? It is often expressed in terms of either concentration. Concentration is nothing but amount per unit volume. Concentration of a product that is formed in a unit of time. Otherwise, concentration of a reactant that is consumed in a unit of time. To measure the unit, otherwise to indicate the units, either we will consider the concentration of a product or concentration of a reactant per unit of time, consumed in a unit of time. Then let us see what is meant by a rate constant. Rate constant is defined as the proportionality constant. This is the proportionality constant. Here R rate of a reaction is directly proportional to the concentration of the reactant. If you want to remove this proportionality constant, we have to introduce one constant. That constant we will call it as a proportionality constant K. It establishes the relationship between rate of a reaction and also rate constant here, which explains the relationship between the molar concentration of the reactant and rate of a chemical reaction. Here let us see the question. At which order of a reaction rate of a reaction it will be equal to rate constant. Let us consider here, if n is 0, if you substitute n is 0, then this concentration of the reactant it will be 0. The power of this one it will be 0. You know from mathematical formula, if you are having any alphabets or number having the exponent 0, then its value it will be equal to 1. Then if n is equal to 0, then this full value it will be equal to 1. Therefore substitute again in this equation, then r it will be equal to k into 1. Then k into 1 it will become k, then r is equal to k. Therefore if you substitute n is equal to 0, it is nothing but 0 order reaction. Only in the case of 0 order reaction, the rate of a reaction it will be equal to rate constant. Therefore correct option for this question is at 0 order reaction, the unit of rate of a reaction it will be equal to rate constant. Here you have to remember, at 0 order reaction the unit of rate and rate constant are equal. Let us discuss next question. The electrophile involved in the bromination of benzene is, here they are asking the question, which electrolyte it will involve in the bromination of benzene. Option A Br plus, option B Br minus, option C Br2, option D Br. Let us discuss in detail what is meant by bromination of benzene or otherwise the mechanism of benzene. Here I am explaining in detail because in Gpstr may be descriptive question, they may ask for 4 or 5 marks. This question explain bromination of benzene in detail with the structure. They may ask for descriptive 4 or 5 mark question. Therefore this is very important. Here they are asking only multiple choice question. They may ask in descriptive type also. Then each and every step is very important. Listen carefully. First step, activation of Lewis acid. Here FeBr3 ferric bromide, this one we will call it as a Lewis acid. It will act as a catalyst. Then what is mean by catalyst? Catalyst, it will help the reaction to occur properly, smoothly, and some catalysts they may help the reaction to occur properly. Maybe it will slow down the reaction, otherwise it will fast the reaction, it will intermediate the reaction, it will regulate the reaction, everything it will do. Therefore catalyst is nothing but it will interact with the reactant. It will help to form a particular product. Then here Fe ferric bromide, then here we are having bromine molecule, this is the reactant. Both they will interact with each other, then you will get a intermediate. This one, how you will get a intermediate? Here listen here. Here this bromine molecule having 3 lone pair of electron, then this lone pair of electron, this it will give to iron, because iron is a electron deficiency. Electron deficiency is nothing but it will easy to accept the electron, otherwise it is deficiency means it will eager to accept the electron, therefore it will accept the electron easily. This bromine molecule is giving the electron, therefore it will accept, it will acquire, otherwise it will possess a positive charge. This iron, it is receiving the electron, therefore it will acquire a negative charge. This is the first step of bromination of benzene. It is nothing but activation of Lewis acid. Here in this step, catalyst ferric bromide, it will react with bromine molecule, then you will get this intermediate. Next step, attack of electrophile by the benzene ring. Here this is the benzene ring, then here the electrophile is Br plus. Then here this benzene ring, it will transfer pi electrons to this bromine, then you can see the electron movement from here to here, then you can see the movement of electrons from here, then here the atom, otherwise the intermediate, it will break here, then it will get a negative ion FeBr4 minus. This is the formation of negative ion. Then you can see the bond formation, then it will detach. Then here after resonance you will get a carbocation intermediate. Why the resonance? Why it will happen here? Because the pi electron conjugated with positive charge center atom, after the resonance you will get carbocation intermediate. Here you can, one thing you can observe, this pi electron migration, it will takes place up to bromine, then again from here to here, then here again. At this point the breakage of bond, it will takes place, then these two intermediate, it will detach at this point, then you will get carbocation intermediate and this negative ion. The next step is deprotonation. Deprotonation is nothing but removal of hydrogen atom. Here you can observe this hydrogen atom, it will interact with this bromine atom, then it will form HBr. Then here this movement of pi electrons from here to here, otherwise this electrons they will move inside, then it will form a bond. Br, it will be remain here only. Then FeBr3, then you will get a final catalyst as it is. This is nothing but a bromination of benzene. Then here the last step is the deprotonation, is nothing but removal of hydrogen. This hydrogen, it will get detached from this carbocation intermediate, then it will form a bond with bromine, atom, then you will get HBr. Then catalyst, finally you will get the catalyst as it is. It will already in the beginning only I told the catalyst, it will help the reaction. After interaction you will get the catalyst back, FeBr3, you are getting a catalyst. Then this aromatic benzene you will get, because you are having 3 pi bonds here. Then one bromine atom it attached to this benzene ring. This, therefore here we can give the name bromobenzene. This is then aromatic benzene. This is an example of an aromatic benzene. Therefore correct answer for this question is the electrophile involved in the bromination of benzene is Br plus. Here the electrophile it is involved in the benzene is Br plus. Here this is the mechanism of bromination of benzene. This is very important. Remember all the steps. It will involve the 3 steps: activation of Lewis acid, attack of electrophile by the benzene ring, and also third step is deprotonation. Here this mechanism you have to practice, then only you can remember, then you can write properly in the exam. Let us discuss next question. Adding salt and sugar to food substance help in preserving them for a longer duration. If you add salt and sugar to a particular substance, you can preserve the food. It is because excess salt and sugar, which process it will involve. They are given the option. Option 1, plasmodize the microbial cells. Option 2, cause rupturing of microbial cells. Option 3, cause changing in shape of microbial shells. Option 4, remove water from the food. Let us discuss the answer. First, what is osmosis? Osmosis, movement of solvents such as water through a semi-permeable membrane as of a living cell into a solution of higher solute concentration that tend to equalize the concentration of solute on 2 sides of the membrane. Osmosis is nothing but movement of water. It will takes place through a semi-permeable membrane. How the movement it will takes place? It will move from solute of higher concentration to a solute of lower concentration. Normally the solvent it will move from higher concentration solute to lower concentration solute. Then up to what extent, otherwise up to what limit it will move means equalize the concentration of solute on 2 sides of the membrane. Until the 2 sides of the membrane they will get equal concentration of the solute. Osmosis is nothing but movement of solute from a higher concentration to a lower concentration solute. It will take place until both the sides of the membrane they will get equal concentration of the solute. Let us discuss effect of osmosis on plant cell. You can see 3 types of solution. One is hypertonic, another one is isotonic, another one is hypotonic. Here in the case of hypertonic, you can see the concentration of the solute will be more compared to concentration of the solvent. Therefore, the solvent it will move from inner cell to outside, because concentration of the solute inside the cell it will be moved. Therefore, from inside the cell to outside you can observe the water movement. That type of solution is hypertonic. Next one is isotonic. In isotonic, the concentration of solute inside the cell and outside the cell, both the conditions also equal. Therefore, you can see the movement of solvent in the inside water. It will move inside the cell also. Water it will come out of the cell also. You can see the circulation of water in the case of isotonic solution. In the case of hypertonic solution, the concentration of the solute it will be less inside the cell. Therefore, the water from outside it will move into the cell. This type of solution we will call it as a hypotonic solution. Then here in hypertonic solution you can observe the water from the cell it will come out. In this condition the cell it will shrink because the water from the cell it will come out. In the case of hypotonic solution, the water inside the cell it will go, therefore the cell walls they will swell. You can see the swelling of the cell wall. But coming to this case, when you had adding salt and sugar to a food substance help in preserving them for a longer duration. What happened in this case? This is the case of hypertonic solution. If you had excess of salt and sugar to a particular food, then the concentration of the solute in the cell it will be more. The concentration of the solute it will be increases. Then you can observe if the concentration of the solute inside the cell if it is increased, then you can observe the movement of water from the cell to outside. Then water from the food it will come out. Then you can see the shrinking, you can observe the shrinking of the food cells. Then you can observe even dehydration. Dehydration is nothing but removal of water from the cell it will takes place. Let us see here. When salt or sugar is added, water moves from inside the cell to the outside solute by osmosis. If you add salt and sugar to a particular food, then you can observe through the process of osmosis the water it will come out, causing partial dehydration. Dehydration is nothing but removal of water. This process we will known as a plasmolysis. Plasmolysis is nothing but if you add water, if you add sugar or salt to a particular food, then the water it will come out. Otherwise, because of the change in concentration of the solute, the water it will move out from the cell. This process we will call it as a plasmolysis, because if you when you are adding sugar and salt to a particular food materials, then the concentration of the solute inside the cell if it is increased, then automatically the water it will move from inside the cell to outside, because inside the cell the change in concentration, otherwise concentration of the solute it will be more compared to outside, that interfere with microorganism multiplication. This it will stop the growth of the microorganisms such as bacteria, fungus and yeast also it will decrease. If you remove all the water from the food, then it will stop the growth of the microorganisms. If microorganisms if it is not grow on food materials, then normally particular food materials it will not get spoiled. Both salting and sugaring have a significant effect on lowering water activity in the food. Therefore, if you add water and sugar to a particular food, then dehydration of water it will take place. This dehydration it will reduces the growth of microorganisms on a particular food. Then you can preserve the food safely. Therefore, correct answer for this question is plasmolyze the microbial cells. Adding salt and sugar to food substance help in preserving them for a longer duration. It is because excess salt and sugar it will plasmolyze the microbial cells. Let us discuss the difference between isotonic, then hypotonic, then hypertonic solution. First one, isotonic solutions are solutions having equal osmotic pressure. In the case of isotonic solution, the concentration of the solute inside the cell it will be equal to concentration of the solute outside the cell. Therefore, you can see the circulation of water it will take place. Water it will enter into the cell, then water it will go out of the cell. Both the process it will take place at a same time. Therefore, it will possess equal osmotic pressure. From inside the cell also osmotic pressure it will be same compared to outside the cell. Next one, hypotonic solutions are solutions having lower osmotic pressure. Then in the case of hypotonic solution, inside the cell the solute concentration it will be less compared to outside. Then you can observe the movement of water from outside the cell to inside it will takes place. Therefore, outside the osmotic pressure it will be more compared to inside. Therefore, in hypotonic solution it will possess lower osmotic pressure. Hypertonic solutions are the solutions having comparatively higher osmotic pressure. In the case of hypertonic solution, the concentration of solute inside the cell it will be more, then the water from the cell to outside it will move. Therefore, the inside the cell it will possess higher osmotic pressure compared to outside. This is the first difference you have to remember. The next one, in isotonic have equal solute concentration. In the isotonic solution, the concentration of the solute inside the cell, outside the cell also same, therefore they will possess equal solute concentration. Then in the case of hypotonic have a low concentration. In the case of isotonic solution, inside the cell they will possess low concentration. The next one, hypertonic have a high concentration. In the case of hypertonic solution, they will possess high concentration because solute concentration inside the cell it will be more. Then isotonic, in the case of isotonic solution, isotonic environment show no effect on cell. In the case of isotonic, the concentration inside the cell, then concentration outside the cell, it will be more. You can observe only circulation of water, it will be takes place. Then there is no change in the size of the cell, it will takes place. Then in the case of hypotonic, hypotonic environment cause cell to swell because in hypotonic the water from outside the cell to inside it will enter, because here inside the cell the water contained it will be more. Then you can observe the swelling of the cell, it will takes place in hypotonic solution. Next come to hypertonic. Hypertonic environment cause cell to shrink. You can see the shrink of the cell, it will takes place in the case of an hypertonic solution, because from the cell the water it will come out. Then if the cell if it is loses the water, normally it will become shrink. Then see the last difference. Isotonic solutions not helpful in food preservative. In isotonic solution, it will not helpful in food preservation because you can see the circulation of water, it will takes place in isotonic. If water is present in the food, then it will help the microorganism to grow. Then it will help to grow the bacteria. Therefore, this condition is not good. The next one, hypotonic solutions are not helpful in food preservative. In the case of hypotonic also, here the water it will move from outside the cell to inside. Therefore, the cell it will absorb the water. If water is present in the food cells, then the food it will help the growth of the microorganisms. Therefore, bacteria it will grow, then the food it will get spoiled. This is also not good case to preserve the food. Last one is hypotonic solutions are helpful in food preservative. Coming to the case of hypotonic solution, here the removal of water it will be takes place. If water is not there in the cell, if water is come out from the cell, then it will cut off the growth of the microorganism and it will stop the growth of the microorganism. Then this is the better case to store the food. Therefore, these are the main differences between isotonic, hypertonic, then hypotonic solutions. Thanks for listening my class. Tell me your valuable feedback. Then only 2 months are remaining for exams. You have to work hard, practice the questions every day properly, and how much possible read science textbook 8th, 9th, 10th science textbook, thorough the textbook first. Then from the textbook only they will ask the concept based question. Therefore you have to understand the concept, then you can easily answer the questions. Please read 8th, 9th, 10th standard if possible. Read 11th and 12th science textbook also. It will help you to clear TET science subject easily. Thank you.